Welcome back to Advanced Control Theory lectures. Today we will discuss a previous year university question. So the problem is, consider the following nonlinear differential equation: y double dot minus 0.1 minus 10 by 3 y dot square into y dot plus y square is equal to 0. For all singular points of the system, classify them and sketch the phase portrait in the neighborhood of the singular point. That is our question. So, in this problem, we have to find how many singular points to this problem or to this system. How many singular points are there, that we have to find out, and we have to find out the type of singular points. So, the first part is to find the singular point, next part is to find the type of singular points and just sketch the phase portrait. So, here that is the third part, just sketch the phase portrait. So, let us start the problem. First, we have to assume that y is equal to x1. The first state variable, we have to take it as y. So, x1, that is the first state variable of the system, and x1 is equal to y. Then x1 dot is equal to y dot, that is equal to x2. That is our first state equation. So, x1 dot is equal to y dot, that is equal to x2, that is our first state equation. Now, here you can see that this is a second order system, hence there will be two state variables, x1 and x2. So, what is the next state variable? x1, and that the next state variable is x2. So, the next state equation is x2 dot. So, what is x2 dot? x2 dot is y double dot. So, from this equation, from the system dynamic equation, we can find the equation for x2 dot. So, for that you have to substitute for y double dot is equal to x2 dot, y dot, we can see y dot here. What is y dot? Y dot is equal to x2 and y is equal to x1. So, substitute these variables here in this system dynamic equation. Now, if we substitute that, we can rewrite the system dynamic equation as x2 dot minus 0.1 minus of 0.1 minus 10 by 3 x2 square into x2 plus x1 square is equal to 0. Now, take all these parts into the right hand side of the equation, then we will get x2 dot is equal to minus x1 into 1 plus x1, because this x1 terms, these x1 terms x1 plus x1 square. So, I am taking this x1 outside from these two terms. Now, it is minus x1 into 1 plus x1 plus this term, that is plus 0.1 minus 10 by 3 x2 square into x2. That is your second state equation. That we can do, whatever system dynamic equation we get, we can rewrite that equations into state equation form. So, from the two state equation itself, we can understood that this is a nonlinear system, because there are so many square terms and cube terms are involved, because you can see here this is minus x1 plus x1 minus x1 square, and this will be minus 10 by 3 x2 cube. So, since these square and cube terms are involved, we can easily understood that this is a nonlinear system. So, in the case of nonlinear system, there may be more than one equilibrium point or singular point. Equilibrium point is it is also called as singular point. So, for a nonlinear system, there may be more than one equilibrium point or singular point, that is multiple equilibrium points may be present in a nonlinear system. After writing the state equations of the system, we have to find the singular points of the system. So, what is a singular point? That we have already discussed in the Lyapunov stability. It is a point where the system state is constant and we can find the singular point of a system by substituting the derivatives of all state variables into 0, or in another way it is singular point or equilibrium point is a point in the state plane where the derivatives of all state variables are 0. So, by substituting the derivatives of state variables into 0, we can find out the singular point of the system. Now, what are our state equations? X1 dot is equal to x2. In this state equation, we can see that x1 dot is the derivative of state variable x1. So, substitute here x1 dot is equal to 0. So, what will happen when x1 dot is equal to 0 in this equation? X2 will become 0. Now, substitute this in the second equation. What is our second equation? The second equation is x2 dot is equal to minus x1 into 1 plus x1 plus 0.1 minus 10 by 3 x2 square into x2. So, here also we have to substitute the derivative of second state variable, that is x2 dot equal to 0. So, we already got x2 is equal to 0 from the first state equation. Now, we have to also substitute x2 dot equal to 0, that is in the second state equation. So, by substituting x2 dot is equal to 0 and x2 dot is equal to 0, that is from equation 1, in the second state equation, our second state equation will be modified like this, that is 0 is equal to minus x1 into 1 plus x1 plus 0. Since this whole term is multiplied by x2, this whole term will be 0. That is why I am writing as plus 0 here, and by substituting x2 dot equal to 0, the LHS of the equation will be also 0. Now, we got an equation like this, that is minus x1 into 1 plus x1 equal to 0. So, this equation, in order to, if this equation is 0, that is if minus x1 into 1 plus x1 is 0, that means either the value of minus x1 can be 0 or the value of 1 plus x1 can be 0. So, there are two conditions here for x1, either minus x1 can be 0 or 1 plus x1 can be 0. So, since there are two conditions, first we are considering the first case, that is minus x1 is equal to 0. What do you mean by minus x1 is equal to 0? That means x1 is equal to also equal to 0. Then our singular point is x1 equal to 0, comma x2 is equal to 0. So, x2 is equal to 0, that we got from the first state equation while substituting x1 dot is equal to x2. While substituting x1 dot is equal to 0 in the first state equation, we got x2 is equal to 0. That condition is not changing. And considering here the first case, so here the first case, that is minus x1 is equal to 0 means x1 is also is equal to 0. Hence, the singular point is, the first singular point is 0 0 or the origin. That means x1 is equal to 0 and x2 is equal to 0. Now, we have to find out the second singular point. How can you find the second singular point? We already have 1 plus x1, either minus x1 is equal to 0 or the second case is 1 plus x1 is equal to 0. When 1 plus x1 is equal to 0, that means x1 value of x1 is minus 1. Then the second singular point is x1 is equal to minus 1 and x2 is equal to 0. Hence, the second singular point is minus 1 comma 0. So, here we have two singular points. The first one is at the origin, that is 0 0. The second one is at minus 1 comma 0. Now, that is our first aim, that is to find the singular point of the system. The next step is we have to find the type of singular point. In order to find the type of singular point, we have to linearize the nonlinear system by using Jacobian linearization. So, in Jacobian linearization, we are selecting two functions f1 and f2. This f1 is the first state equation, that is x1 dot is equal to x2. That is our function 1. Function 1 is your first state equation and function 2 is our second state equation, that is x2 dot equal to minus of x1 into 1 plus x1 plus 0.1 minus 10 by 3 x2 square into x2. So, these are our two state equations. Now, we have to find a Jacobian matrix. So, in the previous problem, I have given a general format for the Jacobian matrix. For a 2 by 2 system, the format or structure of Jacobian matrix will be like this. That is, the first row is dou f1 by dou x1. The next element is dou f1 by dou x2. The second row, first element is dou f2 by dou x1 and second element is dou f2 by dou x2. This means that in the first equation, that is f1, we have to differentiate the first function with respect to x1 and we have to write the value here. So, take the first function. First function is x1 dot is equal to x2. That means your x2 is your first function. You have to always write this part of the equation. So, x2 is your first function. So, while finding the derivative of this function, that is x2 with respect to x1, we can say that it is 0. This is why I am writing here 0, because derivative of x2 with respect to x1 is 0. Now, take the first function itself, that is x2 itself, and find the derivative of it with respect to what? x2, that is your next element, dou f1 by dou x2. So, while derivating, when you find the derivative of x2 with respect to x2, it will become 1. So, here in this element it will be 1. Now, take the next function f2. f2 is equal to minus x1 into 1 plus x1 plus 0.1 minus 10 by 3 x2 square into x2. Take this whole function. What is the second row first element? Dou f2 by dou x1. That means, in the second function, find the derivative of second function, that is this function with respect to x1. So, if you find the derivative of this term, it will be minus 1 minus 2x1. If you find derivative of this term with respect to x1, this will become 0. Since this is 0, I am representing only minus 1 minus 2x1. So, this element is derivative of the function f2, that is this equation with respect to x1. So, if you find the derivative of this equation with respect to x1, you will get minus 1 minus 2x1. Then the next element is dou f2 by dou x2. That means, find the derivative of the second function, that is this equation with respect to x2 alone. x2 alone. That means, this equation will be 0.1 minus 10 x2 square. So, this is your Jacobian matrix.